Hi there everyone, it's Mrs. Ortiz and we are covering Objective 2 for the 4th unit, which is on quadrilaterals. And today we're going to talk about the parent function and graphing parabolas. So we're talking about the quadratic parent function and then parabolas. So our essential question today is, what is the quadratic parent function? And also, how do you graph a quadratic function? So let's start with the idea of a parent function. Remember that a parent function is the most basic function of that family. Most basic function of that family. For quadratic functions, the parent function is f of x equals x squared. So use the table of values and plot the points, graph the parabola, then answer the questions about the key features of the parabola. So remember that the function here is f of x equals x squared, and so we're going to fill out this table for that function. So if f of x equals x squared, we're going to, we could plug in a -2, a -1, a 0, a 1, and a 2, and see what our output values are. So when we plug in a -2, remember we're evaluating f of -2. I'm going to zoom in so we have some space to do this. So we're evaluating f of -2, which means we're substituting a -2 in for x, and we're squaring it. And remember, you want to protect your numbers by putting them in parentheses, because when we square a -2, our output is a +4. When we evaluate f of -1, we're going to put a -1 in for x and square it. We get a +1. F of 0 means we're going to substitute a 0 in, square that, we still get 0. F of 1, we're going to substitute a +1 in, square that, that's equal to 1. And f of 2 is equal to 2 squared, and 2 squared is 4. Okay, so there are our input and our output values. And so we are going to plot these. And remember, this is for the parent functions, the most basic version of a quadratic function. Okay, and also remember that a quadratic graphs. The shape is called a parabola. So -2, 4 is a point that fits on our graph. -1, 1 fits on our graph. 0, 0, 1, 1, and 2, 4. Okay, and so remember, our parabola is a nice soft U shape, and it's going to look something like that. And that is the graph of the parent function. So then we have these series of questions from the features that we talked about yesterday that we need to answer about this graph. So the first one is, what is our y-intercept? So our y-intercept is this point here where it crosses the y-axis. So that's the coordinate 0, 0. Make sure you write that in coordinate form. What is the x-intercept? Where it crosses the x-axis? Well, that's only at that place, which is also 0, 0. Okay. The real roots are x equals 0. There are no others. The axis of symmetry is the line, the vertical line that divides the parabola in half. So it's the equation of this green vertical line, which is x equals 0. The vertex is also the coordinate where the graph has a min or a max. So that's at 0, 0. And this graph has a minimum of y equals 0. All right, so there are our features for the parent function. So when we say the most basic, notice all of these zeros in here because it's centered on the graph, it's positive, it's not stretched or compressed. So everything does really remain very basic. Okay, so before we get into some more graphs, let's practice evaluating some quadratic functions given a value. So I'm going to do 1 and 2, and you are going to do 3 and 4. So let's take a look at number 1. It asks us to evaluate when x is equal to 12. So we're going to find f of 12, and that's equal to, we're going to replace the x's with a 12. So 12 plus 3, quies squared, minus 2 times 12, quies squared. And remember to protect your numbers with parentheses. So then we need to evaluate inside the parentheses first. 12 plus 3 is 15. So f of 12 is equal to 15, minus 2 times 12 squared is 144. And I dropped my squared here accidentally. Okay. And then we're going to evaluate each of these. So 15 squared is 225. And 2 times 144 is 288. Okay. So when we evaluate this, f of 12 is equal to, let's see, what is that? Is that negative 63? Okay. All right. So number 2, let's do that one. We're going to evaluate f of x when x is equal to 6. So we're going to do f of negative 6. We'll zoom in here. Is equal to negative 5 times negative 6 plus 4 times negative 6 quantity squared. So replacing this x and this x with negative 6 and keeping everything protected by putting it in parentheses. So f of negative 6 is equal to negative 5 times negative 6 is a positive 30, plus 4 times negative 6 quantity squared is a positive 36. And then we've got 30 plus 4 times 36 is 144. So f of negative 6 is equal to 30 plus 144. And all of that simplifies to 174. All right, so hopefully I did not make any errors in my arithmetic, but you might want to double check me. Okay, so just a review on how to evaluate quadratics. Be very careful on this one that you plug in an 11 in the parentheses, because this negative right there is going to make it the opposite. Okay, so make sure that you're very cautious about that. So you're going to do number 3 and number 4 on your own. Okay. All right, so now that we've practiced evaluating quadratic functions again, let's go back to the idea of graphing them. So what we're going to do is we're going to graph these parabolas using a table, and we are going to place the vertex where the graph turns around, that turning point, in the bold box in the center of the table. It says, show your work to evaluate each value in the table. So the function is f of x equals 2x squared minus 8x plus 9. The first question that we're being asked is, what is the form that this quadratic is written in? And this quadratic is written in ax squared plus bx plus c form, which is standard form. Okay, so we're identifying the form as being standard form. And then in order to graph it, we're going to use these x values in the table and evaluate each one of them in the function form right here. Okay, so first we're going to evaluate f of 0. So we're going to substitute zeros in for x's. So 2 times 0 squared minus 8 times 0 plus 9. Well, 0 is 0 times 2 is 0. 8 times 0 is 0. And so all of this adds up to 9. We're going to put that in our table. And we're going to keep evaluating these. I'm going to zoom in so I have enough space to get this done. So f of 1, so 2 times 1 quotient squared minus 8 times 1 plus 9 is equal to 1 squared is 1 times 2 is 2 minus 8 times 1 is 8 plus 9. So 2 minus 8 is negative 6 plus 9 is a positive 3. And we'll add our numbers in the table once we finish. Let's find f of 2. So 2 times 2 squared minus 8 times 2 plus 9. 2 squared is 4. 4 times 2 is 8. 8 times negative 2 is negative 16 plus 9. So 8 minus 16 is negative 8 plus 9 is a positive 1. We're going to evaluate f of 3. So 2 times 3 squared minus 8 times 3 plus 9. 3 squared is 9. 9 times 2 is 18. 18 times 3 is negative 24 plus 9. So we've got 18 minus 24 is negative 6 plus 9 is a positive 3. And f of 4 is 2 times 4 squared minus 8 times 4 plus 9. 4 squared is 16 times 2 is 32 minus 8 times 4 is 32 plus 9. And 32 minus 32 is a positive 9. Okay, so we're going to go ahead and fill out the table. Let's see here, straighten this out a little bit. So fill out the table with the rest of those values. So we've got 9, 3, 1, 3, 9. And we're going to go ahead and graph it as well. So we're going over 0, up 9, over 1, up 3, over 2, up 1, over 3, up 3, and over 4, up 9. So compared to the parent function, so if we connect all of these, we have 5 points. We need at least 5. And we're going to try to do a nice soft U shape for the parabola. But compared to the parent function, this graph is moved, the vertex is moved off of 0, 0. It's stretched out a little longer and thinner. And so those are just different ways that you can kind of compare it to the parent function when we call those transformations. So being shifted, stretched. And if it was flipped and pointing downwards, then we would call that reflected as well. Okay, so then we need to answer some questions about the characteristics of this graph. So first of all, the y-intercept, where it's crossing the y-axis, is at that red point, which is 0, 9. The x-intercept is where it's crossing the x-axis, and it never does cross the x-axis, so there are none. Okay, so no x-intercepts, which means there's also no real roots, okay, because it's not touching. The axis of symmetry is that line, that vertical line that divides the parabola in half, and it goes through the vertex. And so it is a vertical line, which means it is an x equals equation, and it's at 2. So it is the equation x equals 2. And the vertex of our graph, where our graph turns around, is at 2, 1. Okay, and then finally, this graph has a minimum because it hits at the bottom, okay? And the y value for the minimum is a positive 1, so y is equal to 1. Okay, so those are many of the key features. The last question that we are asked to talk about are the domain and the range. So for the domain, remember we are looking how far left and how far right does our graph go. And our graph, it continues both upward and left and right. So our domain is going to go all the way from negative infinity to a positive infinity. And then our range is going to go from our low point, which is a positive 1, all the way up towards infinity as well. Remember, we can't ever quite get to infinity, so we give it a hug because we feel bad for it. It gets left out of the party. So that's my goofy way of remembering that infinities get parentheses. Okay, so that is using a table to graph a quadratic. So you are going to work through number 2. And then for the rest of this lesson, what we're going to do is do it on another video. So the rest of this lesson is going to graph parabolas using calculator technology. So you can see that on a separate video.